And in today's class we'll be taking up the next problem on projection of lines. I have signed in using the student account, and let's go for my courses, get into engineering graphics lab, and yep, so there was one problem left unsolved. That was twisted problem on lines. Let's go ahead and do that. So I had already started attempting it, so let's go ahead, click continue attempt, keep it at the side. Let us do that. And on this side I already have a template. This problem we had solved in the previous class. Let's go ahead and solve this problem that we have today. So in order for us to solve this problem, we'll have to take this line as a reference. So what I'll do is I'll just take this data, let me place it over here, let me match the properties of this text onto this. Looks good. Let me remove the extra spaces that are present over here. All right, so now we are ready to solve the particular problem. So I was telling that we have to use this diagram as a reference. Okay, so let's do one thing. Instead of going for a tinting, let's go for take a review. All right, so this diagram needs to be taken as a reference in order to solve this particular question. In fact, there are a lot of different questions with different quantities being given as input, and you're supposed to complete the diagram and put in the other values that we are supposed to. Like here we even provided with the distance of P above HP, distance of P in front of VP, true length, front view length, and then inclination of PQ with HP. So these data needs to be fed into the diagram. Okay, so here we have to identify whatever data is given, and we have to draw the diagram based on whatever data is given. Once that data is drawn, we need to complete this diagram. We need to complete this diagram. So this is more like solving a puzzle. If you have solved Sudoku, I think you know what I mean. Sudoku provides us with a few numbers, and we are supposed to fill in the other numbers. And at the end, there is only one unique solution for every Sudoku puzzle. Same way here as well. For the given data, there is only one diagram possible. There is no other way it could be drawn, and that's the reason why we know in the question all these input values have been asked, which you are supposed to fill in. And once you fill in the value, this value will be cross-verified with the actual value that I have fed it earlier. And if the value is within 1% of error, you will get full marks, and if it is not, then you will end up losing some of the marks. So let's go ahead and start doing that. So let's identify what data is given first. We know the distance of P above HP, which is over here. So the distance of A dash from the XY line, that is given, and the distance of top E of A, that is again given in this particular problem. So instead of 10, the value is 6 over here, and instead of 25, the value is 17 over here. So the true length is given. So true length appears over here, that is 100. That means this line A dash B1 dash, and then this line over here A B2, those are the two places where true length actually occurs. And then we know the front view length, and okay, so the front view length occurs over here. This dark line that we see here, that is the front view length. And the same length also occurs here when it is horizontal, A dash B2 dash. and a dash b dash, both are of same length. Okay, so when a front view length is given, you can start either drawing it in the horizontal position if you don't know the angle, and if you know the angle, you can directly draw it in the inclined position. And then finally, we know the inclination of PQ with HP, that is theta. So theta angle is this angle here, the angle of a dash b1 dash with xy line. Okay, so let's go ahead and feed in the values that we have been provided. So first of all, we'll have to start by drawing an xy line, and then we'll have to turn on this and nearest option. Start at some point in upper direction, the distance is 6, and from here in the lower direction the distance is 17. So at this point we'll have to give some naming. Okay, let me copy the text from over here. This is X, this is the front view, the line name is PQ, so this is got to be P dash. This is the top view, so P. So this is the first two data that have been provided. We have fed them already. Now we have been given the true length and front view length, and true length and theta both are known, so we can directly draw this line over here, a dash b1 dash. So here that's going to be p dash q1 dash. Right, so let's go ahead and draw that. So for that we have to turn off ortho mode. We should keep the dynamic input mode on. Let's click over here, and we have to give the true length. Fine, so we can press tab to shift between angle and length. So let's go ahead, take length is 90. Let's press tab, and now you can see the length has got locked. We are able to change the angle, and the angle is 23 degrees. So let us feed that and again press tab. Now you can see both length and angle have been freezed, locked. So I can press enter now, and then I need to turn on the ortho mode, come down here, then draw a horizontal line from here. Okay, so that gives me the other point. So what is the other point? That is b1 dash. Right, so here the line name is PQ, so it's got to be q1 dash. It's got to be q1 dash. And okay, this lower point is the top view of q1 dash, so it's going to be just q1. So this we were able to draw. Fine, so this data, true length and the angle with HP, we have utilized. Next thing that is given to us is the front view length. And now if you observe here closely, we have this horizontal locus, and then yeah, so if we this horizontal locus and this length both are known to us. So let's go ahead and draw that. So let's take a horizontal line from here, and then the front view length from here we have to measure that length as 68. Now in order to do that, we will have to use compass when you are doing manual drafting. Here in AutoCAD we'll be using a circle. To take a circle, click here and give the radius as 68. Now because the circle has the same distance from center in any direction, though it will be 68 in any direction, we want the intersection between these two as a point. So let's go ahead and draw that. So intersection of these two up to here. So this circle we might actually keep it. So you can see here there is an arc coming all the way down here up to this horizontal line. So let's draw that horizontal line and trim the circle which is outside. Okay, so we just need this point as the final point. This is Q dash, and of course we will need the legend. It should be exploded. Let's keep it over here and apply match properties, MA solid line onto this. So this is our dark line, as you can see over here as well. Okay, so this is our dark line, which is the front view, and we have taken the circle to get its measurement is 68. It is matching here with this locus point, and here all of the given data has been utilized. Now using this diagram as a reference, okay, of course there are a lot of titles and everything that is overlapping it, but you understand my point. Fine. So you can use any of the diagram that you have drawn earlier as a reference to complete this particular thing. Fine. So you can assume that this is like the Sudoku problem which is given to us. Fine. And we need to complete the diagram. We need to get all these lines. Once we get all the lines, the diagram will be complete, and then we'll be able to feed in all these values that he's asking us to feed. So let's go ahead and start solving it. So first thing is, you can see from this point is B2 dash. So for us here, it's going to be Q2 dash. Okay. And from Q2 dash, we have to take a straight line, and that line intersects the true length. Okay, so we already know the true length. We don't know the angle of the true length, but we certainly know what is the length of this line. So that's what we have to take. So let's take a line. From here, you have to take a straight line. You don't know the length. Okay, and then from here, the distance of Q2 will be at true length. So whatever is the true length, okay, so this here is the true length. The same true length we have to take over here. We need the intersection of that. Okay, so that intersection point gives us the point Q2. That gives us the point Q2. Fine. And this Q2, when we touch it here, this will give us the true length, and the angle between these two will give us the inclination with VP, actual inclination with VP. Once you know this point, we have got this point. Now from here, we need a locus here and then an arc from here. These 2 points will intersect at the final point top, or final top view of the point P. So let's go ahead and do that. So take a line from here, go horizontal, and then take a circle, this point, passing through this point. And then we need this arc only between these 2 lines. So let us trim off the other part. Okay, so all right, let's keep this, come on, aside, and this point is going to be Q. This point we have to touch it here, and this has to be dark. Fine. So let's match the properties of solid over to this. So this is our final top view, and this is our final front view. Now in order to verify whether our diagram is correct or not, we'll have to draw a line from this point straight. Don't just draw it here, we just need a vertical line. Okay, and no matter how closely you watch this has to be perfect. Okay, if it is not perfect, that means somewhere you have made a mistake, and there is a need to go back and check where we went wrong. Okay, so once having done this, I think we are now ready to feed in most of these values. So first thing he's asking is the inclination of PQ with VP. So for that, I'll have to take the dimension of angle. Okay, first let me show all the lengths that are given in the question. So for this question, this value is given in the question, and then we have this that is given in the question, and we have the true length given. So let's feed in the true length. Okay, we'll have to take aligned dimension for that. Let's take true length over here and true length over here. Then theta angle is given to us, so let's go ahead and put angular measurement of theta. This here is theta. Okay, so let's move this slightly over here. Come on, let's move this over here. Okay, and then yeah, we have to apply this property over here. Fine. So match property, enter, take this property and apply it on all these dimensions that we have applied till now. After having applied that, you have to find all the measurements that we are supposed to. Okay, so first thing he wants us to find is angle phi. So let's go ahead and find angle phi. Phi is the angle between this line and this line. So let's go ahead, take okay, where did it go? Here it is, angular measurement between this and this. So this angle here is angle phi 41. Then top view length. Top view length is the length of this dark line over here. So let's go ahead and take that aligned length over here. So this length is the top view length, 82.85. okay, so you see that is the reason why you're supposed to be able to solve this particular question, right? And that's why I've given the marker, drop marker type question here, so that you can become familiar with all these points. Now of course there is some error going on with the Moodle. I don't know why, because some of the markers are randomly shifting as soon as you press the submit button, and some of them are getting wrong that way. But it I think 75, about 75% of these markers will remain in position and they will fetch you marks, and that's a little encouraging. Now slight discouragement is there definitely, but you can just keep trying it. So the important thing is that you know the name of all these different lengths, all these dimensions. Okay, so if you're not familiar with any of these, then it's going to be very difficult for you to solve this. Fine. So not just that, even the name of the different lines and arcs also needs to be known to you, because this terminology will be used in the question to define the given data. And if you are unable to make out the given data, you will not even be able to complete the question part. Whatever data is given, even for that you will not be able to draw this particular diagram. And as I told earlier, problems, all these problems are like solving Sudoku quiz, wherein some boxes will be filled with numbers and the other boxes need to be filled based on the logic of the given data. Okay, so this is the logic, this is the answer key which you are supposed to understand, which you should know just like the back of your hand. And if you know this perfectly, then almost any problem on projection of lines you will be able to solve. Okay, now there are problems wherein the distance of traces will be given. So those problems are a bit difficult to solve with exactly this using as a key, but for us, of course, we are not using the traces for now, so you can easily solve any problem wherein the trace is not present if you know this master diagram perfectly. Okay, so the front view and top view have been drawn, and okay, let's see what other values we have to find. Apparent inclination of the front view with xy. So front view inclination, front view is this line, and apparent inclination is its inclination with xy line. So let's go ahead and take this angle. So we can take the angle between these two, or we can take the angle from xy, whatever looks good to you. I think let's go ahead and take with xy so that it gives us some space. Okay, so that is 31 degrees. Then apparent inclination of top view. Okay, so top view is this dark line over here, and its inclination with xy line we are supposed to measure. So click this, and keep it at some distance. Okay, so if you can keep the text which is not overlapping with any of the lines, that's much better. So this angle here is the apparent inclination of the top view. And distance between end projectors. End projectors are the lines touching P dash and Q dash. Right. So this line over here and this line, these are the end projectors. So we need to find the distance between them. Let's go ahead and do that. So okay, so we'll need snap option to be on. This is the distance we are interested in. So let's drag this a little towards the side so that it doesn't overlap, and that is distance between end projectors 52.8. Then distance of B from HP. Once again, you can use this value over here. So this point, this value given over here is the distance of B from HP. Okay, and this distance over here is the distance of B from VP. Of course it's overlapping here, so it's not visible, but anyway, that is what the right answer is. So let's go ahead and find what is needed. We need the distance of B from VP, which means distance of this point from XY we need to find. Let's go ahead and find that. Okay, so we'll again need OSNAP option to be on. Let's take this. This is the distance of B from VP, 75.95. So you can see that we have fed all the answers except for this one. The line is parallel to. Fine. So in this particular position, it is inclined to both the planes. This is the actual inclination with HP, and this is the actual inclination with VP, and that's the reason why it is inclined to all the planes, and it's not even parallel to PP. Okay, if it is parallel to PP, the sum of theta and phi will come out as 90 degrees. So the correct option here is none. It is parallel to none, and all these values we need to feed in like this. Okay, distance from okay, there's one more distance of B from HP is also asked, so let us feed in that value. I don't know how I forgot to do that. Okay, let's do that as well. So that is 41.15. So like this, you need to complete the diagram. You need to complete the diagram, and then from the diagram you need to take all the measurements using the, this diagram and this diagram as the key. You need to find whatever lengths are being asked in this answers, and then once you've fed it, you just click on finish, and yeah, finish, submit, and finish. It will verify the answers, and if the answers are within 1% of error, you will get full marks. So you can see here I got all of the marks. So in some cases the angles may be having an error of more than 1%. Fine, because the template by default will round off the angles to 0 precision. That means after a decimal no digit will be shown. If you want to see what value lies after the decimal point over here, if you want to increase the precision of the angle, you will have to go for a command called de-enter. De-enter is a command for dimension settings. Click over here. Okay, sorry. Click here, modify, and then okay, so round off value here. This is the angular dimensions. Increase this over here. Of course, you have to suppress the zeros, close, and you can see here after decimal point one more value is being shown. So if this value happens to be more than 1% of error, 1% of this value, then you will end up losing a few marks, right? So if you want complete 100% marks, then I suggest you to go ahead and take these values. So here also you can see this is 0.4, which lies within 1%, hence I was able to get full marks. But if it is outside of 1%, then you'll end up losing some marks. If you don't want to lose, you'd have to do it like this. So I hope this stream was useful to you. If you want more streams like this, please support us by subscribing to our channel, by spreading the word about our channel. Okay, because I'm not spending much on the publicity, so my viewers are all I have, and hopefully you will just share it to your friends, more and more of your friends, so that I get enough viewership, and I remain encouraged to develop more of these videos free of cost and make it available to you all. So thank you for watching the stream. Hope you will continue to support us. We'll see you in the next stream, I think on projection of planes. If you want more problems on projection of lines, you can just let me know. You can put in the question in the comments, and if I have time, I'll be solving it out in the next stream. Goodbye then. See you.